Yay! Oh, happy weekend, everyone. Who doesn't love a good software bug? I've got so many of them. We got more bugs than Hollow Knight going on this stream.
We found all of them.
Every single one.
We found one in OBS Ninja. We found one in OBS. We found one in the audio software. Oh, it's a good day. It's a good day.
Shout out to Voice Meter for still working.
Yeah, Voice Meter is still kick ass.
Yeah, Voice Meter has not hit anything yet. Let's give it the shout out before it's like, I want to be called out too, and just decides to screw off. So if you were watching the intro, if you're watching this recorded, you didn't see what happened because I've cut it out. But if you were watching the intro and you saw all the graphics disappear, that happens every time you change or turn off studio mode. Anything that's an image loaded from a file on your hard drive just vanishes from the scene. Specifically, it keeps loading the URLs from the web that I have for load images from the web, but anything locally loaded off the hard drive, poof, gone. I don't know that one. That one's super confusing. It would make more sense the other way around.
It would make a lot more sense the other way around, but unfortunately that's not fortunately, I'm
unfortunately,
not sure.
90% of the scene is
happen that
saved
way.
files, so that if anything happens to whatever reason, I have a failure to load resources off the internet or something, which it's totally possible, it doesn't break. So I saved everything to the drive, and now those don't load.
Software. Turns out what we work on is incredibly fucking complicated, and there's a lot of things that can fail.
Yep. I shared that meme that Pseudo shared, and it needs to be said all the time now. Give a man a program. Frustrate him for a day. Teach a man a program. A man a program. Teach a man to program. There you go. Words. Frustrate him for life.
But when you overcome small pieces of frustration from programming, best feeling in the world.
Yeah.
It is a roller coaster. It is most definitely a roller coaster. And this also applies to game programming. One hell of a roller coaster.
Oh, yeah.
You think these bugs are bad. When you get into game programming, those bugs will drive you nuts because reproducing them is a nightmare, and is debugging them is a nightmare because you can't run traditional debugging tools and step by step because then you're not at the same case, and also the game just won't run very well because optimization is key and debuggers are slow.
Is the reward worth it? Entirely depends on your personality.
Yeah, it's definitely not for everybody. It's one of those things where it's like problem solving and puzzles. If you like puzzles and you like problem solving and you like those kind of things, then it'll be worth it to you. But that's obviously not for everyone, and those things can be incredibly frustrating.
Making sure the mic doesn't fail now.
No, there was a really annoying car alarm going off behind me, and I didn't even have to mute.
Yeah, the RE20's got great isolation.
Yeah.
I did not hear that at all.
Yeah, I love this mic. I love this mic with a passion. It's a fantastic mic. I may have done a lot of things wrong on this show, but the mic choice was not one of them.
You're welcome.
I'm going to shrink this. Yes, the video that you sent me for different samples of mic was super handy. It was.
I should probably not be trying to put together a pull request for OBS Ninja while we're doing the show.
Probably not. Probably not. I'm more of a perfectionist, so I stayed well away from programming. I'm quite a perfectionist too, and also an extreme pedant, and it's been nothing but good for programming.
Yeah, it can work. Perfectionist is a good trait to have, especially depending on what the kind of code you're writing, because there's a lot of stuff where it's very complicated and you need to be sure things are going to run well and they're going to run right. And I'm very much on the opposite end of that spectrum. I'm more of a have it run, and there's a perfectionist on the team who will correct my shit, and hope to God they figure it out and tell me what to do. But there's a lot of small things that need to get caught that don't. But there's a nice balance between getting things done in a reasonable amount of time, as well as being able to prototype something out, versus having someone with that mindset of it needs to run perfect. Especially for game programming, optimization is key. We'll talk about it a bit more in a sec, but thankfully for now, engines kind of offload most of that stuff. But traditionally, when you were writing games, you had to be on top of everything. If your render pipeline, your memory management, everything needed to be up to snuff and like as good as it could really get. Because if it's not, your game's not going to run in the 16 milliseconds it needs to. So it's
which, for the record,
good trait
is
to have.
Tiny amount of time. Tiny amount of time.
I've only worked in one piece of software that had tighter time requirements. And having tighter time requirements than a game is fucking stupid.
Yeah.
It had to read, calculate, and store the information from every packet that came in within 10 milliseconds.
How did the storage work? Oh, it must have been a RAM disk that then got persisted out to DB.
The storage was a Elasticsearch cluster.
Yeah, so RAM disk that gets persisted out.
Well, it's not quite a RAM disk, but it might as well be at that point. It was a 4-node. There was a 4-system cluster for the most basic implementation of that software.
Did you know, fun fact, Elastic can now run inside video card VRAM?
I did.
I did not. That's cool. I did not know that.
Yeah, you can
I
run your
learned a
whole
thing.
DB in VRAM. I don't know why you would need that much performance. You've probably fucked up somewhere else if you need that much performance from your DB. But it can.
Finally, all that VRAM I have is going to come to use.
I see it being really useful for a lot of social media applications.
I still would say that you've fucked up somewhere else. You don't need fast reads
yeah,
off of,
you
for
don't-
social media. You need eventual replication.
You don't need, but it will give you an edge over everyone else eventually. And right now, there's so much money in that world. So much money in that world. Any edge, despite the cost, is going to be worth it pretty soon.
For marketing purposes, sure.
Yeah.
Like the
I mean,
data
usability,
collection
it's
and
already
processing.
usable. It's fine. Like, who cares if it takes 5 minutes to find out that somebody liked your video? It's not a big deal.
Not a problem.
No, but these discs will now hey, when somebody likes your video, you'll fucking see it right away. It's an edge. It's not a great edge, but it's a marketing edge. That's where I see these being used.
Yeah. It's more useful for things like Firebase or Firebase alternatives, where you want your real-time updates, and the DB is more event-driven rather than transaction-driven. But yeah, we're in the weeds now.
Oh yeah. Oh yeah.
Yeah, if you don't like databases, you might like game programming because you do not have time for transactions unless you're doing multiplayer stuff. But for the most part, everything's just kind of you load it into memory. It is going to be a fun time. You're going to be very appreciative that computers nowadays have actually way too much memory, and you'll kind of see that games are the kind of only program that really, or mass consumer program that really use up, that 8 gigs of RAM that is kind of commonplace in most laptops and consumer desktops today.
Well, I mean, I have opinions on state management.
Yeah, but it's for because the main thing we we're talking about before is optimization, and that's the first thing you're going to want to do is just, if you can, put into memory. Memory is fast, almost as fast as you can really get. And you're going to see a lot of examples, or some examples will show where there's going to be variables and all other stuff, and there's going to be hundreds of them, and it's just game startup, just throw everything in memory and just hope to God that whatever garbage collection, if it's a language garbage collection, doing it for you, you've got to hope to God that it's efficient.
Unity.
Don't use Java.
Optimizing that project I had was a time. It was a fun time. It was not a fun time.
All right.
But the thing, there's so many things to talk about with this, but choosing a language like Java, it potentially could work for game development if it had a long enough runtime, and you gave the JVM enough time to actually optimize for the code path it's taking. But we're not talking about a couple of hours of gameplay. We're talking about this application has been running for months, and the JVM has self-optimized to the point where it's just completely dropped branches that aren't going to be hit, and taking the needed path and making that as fast as it can. But that's optimizing bytecode at the machine level.
That's what was happening in that 10 millisecond app I was talking about. It was a 4-node Java cluster. And they just got up and running. And they were actually made, okay, if you're at all interested, the cluster was made to monitor industrial energy grids and was taking IoT packets from all of the electric meters across a province or state in real time. And then not only calculating where all the stuff is and how efficient it all is at any given time, but also calculating for inefficiency in electric routing and issues with routing. And at any time, you could go in and click on any meter and see the exact route of how energy was getting to that meter.
Which is kick-ass software. I would not want to be responsible for doing that.
I ran the knock for that place. It was fun.
Oh boy.
It was fun. It was actually fun. I enjoyed that knock. You feel like such a badass when you're in it, because the wall was just 3x3 60-inch screens just flashing data from across the world at you constantly.
Like command center. I think I saw that, 'cause you took me to the office one time and it looked badass. It just looked like a CIA command center. So much stuff.
That was it. Yeah, that place was fun. All right, let's actually make this interactive. This is just us rambling so far. Viewers, what do you want to know? Where do you want us to start? Questions. This is not a wait for the question and answer segment. Shut up and listen to us. That's not how we do things. You all know this by now. Throw the questions. You got anything you want to know about video programming? Throw it out. Don't necessarily have to wait for us. If we say, we'll get to that in a minute, we'll get to that in a minute. Pseudo, you're the smart one here. Where do you want to start?
I think we should just start with the main thing that, the main question that most people have when they think about game programming. From my actual, previous programmer experience is, how is it different from, other traditional means of programming? And even people who haven't programmed before are probably going to be curious on, is there a difference? And if there is, what is the difference between, programming and what everyone talks about game programming? Because, spoiler, there is quite a bit of difference. It's still all kind of the same thing you're doing. It's just you're going to be doing things in a different method. And they're kind of, in the software world, they're typically just called patterns, software patterns. And the software patterns you're going to be using to create like a web application versus creating a game are going to be quite different, as well as just kind of the structure that goes into game programming is kind of a lot different, because there's just so many layers that go into it, because games are very, very complicated applications. You have everything from, you're rendering to graphics pipeline, which is actually displaying what's on the screen, to, taking in the player input from, hardware controllers, from keyboards, from, actual gamepads, to even stuff like the Guitar Hero controller. That's all hardware signals being sent in that need to be processed and then sent to the software, and the software needs to interpret it and figure out what the hell to do with it. There's a lot of layers to this, but the main one we'll kind of touch on and focus on is just actual kind of game object behavior programming. It's also known as kind of just game scripting. It's the kind of main thing that most people will be actually doing when they're game programming nowadays. At least what they kind of should be doing if it's your first time. And I heavily suggest that if you haven't done game programming before, even if you've programmed, let's say web for 5 or 10 plus years or whatever, you're an established programmer, or if you're new to programming, I heavily suggest picking up an engine for the first time, kind of exploring this field.
Absolutely. And if you're just new to programming, period, learn your patterns. As a new programmer, I found absolutely nothing more beneficial to my advancement of programming than learning patterns.
It's something that is very, very missed and understood in the academic sense for programming. And even programmers that have gone through the schools and school systems, there's never really courses that really expose you to patterns. And patterns is kind of like when you actually get to the meat and potatoes of implementing what you want to do, you're going to want to know patterns. And these are things, the typical reason why they're not included in the academic sense is because they change very frequently. They kind of, evolve with the ecosystem of the language and evolve with the ecosystem of, the actual development world. But they're very important. It's kind of just what people are doing, what people are using to solve problems. It's the solution to things. There's way too many to really dive into a lot of them right now. There's lots of books on the subject. There's lots of kind of general software patterns. And there's also game programming patterns. There's one book I can recommend, and I've read it, and it was really interesting. It's kind of a bit on the lower level side of things. It kind of talks a lot about kind of like memory management and stuff like that, but it overall is a very good read and kind of exposes you to kind of what goes into game programming. And I'm just trying to find the author's name, Bob Nystrom. And the book is Programming Patterns. I believe there's ebook versions and PDF versions. I think he might have a web version that is free, so you don't actually have to buy a version. You can just view his whole book on the web. I'll actually just post that in our Discord.
I was going to say we'll actually pin that to the game dev channel in Discord. So if you're not in our Discord and you like game development, join the Discord. What are you doing? What are you waiting for? If you are already there like you should be, that will be pinned in there as a permanent resource for you. Who did you say the book was by?
Bob Nystrom.
Nystrom?
Yeah. It is. It won't really, it's not going to teach you how to program the games, but it's going to kind of give you an exposure to what goes into it. And especially if you're coming from an established programming background, it's going to be kind of nice to see, what there is. And if you're coming from that background, you're of course aware of other patterns, and you're going to kind of see what is actually required for games to run and the problems that these programmers are running into and have to solve. And it really kind of boils down to just efficiency. Even if you're just doing game scripting, you have to be very careful to make sure that your logic is as efficient as it can be. Even something as simple as a for loop over like an array of objects that you have, or a for loop to go through it. So you have a bunch of enemies, and if you're looping through those enemies, if you're not careful, your game could be running fine, but all of a sudden 2 or more enemies come up, and then all of a sudden your script for this one behavior to run is just the performance is tanked, and all of a sudden you're going from a solid 60 to a 20 to even maybe like a 10 depending on the case.
The people can actually
single-digit frames.
You can see excellent examples of this if you play any retro games on those old hardware or old processors. Collision detection, distance, and stuff like that from 2 objects is really costly, actually. And as you get more and more objects on a screen, it's got to do more math between more points to see if anything is colliding with anything. And that's why on those old NES games, you see 4 or 5 sprites hit the screen, all of a sudden, oh, I'm chugging. That's what that slowdown that you're always talking about in retro games is. Literally just processor couldn't keep up.
And that's one of the reasons why data structures are so important. Like being able to structure your data in such a way that you can do not necessarily iteration, but retrieval of data very, very quickly is very important, especially if you're writing a language with expensive traversal, like JavaScript, for instance. Not that you should be writing a game in JavaScript.
No comment.
Scripting a game in JavaScript is a very good idea. But yeah, not system level stuff. Scripting is fun. You can script in almost everything, and that's why you'll see a lot of game engines, even like Godot and stuff like that, have their own bundled scripting language with them, because writing a scripting language isn't, it gives the engine developer a lot more kind of control of what the future users will be able to do. But overall, it also simplifies, everything, because game scripting and programming is very simple compared to kind of other means of programming. You're not going to really need control over a lot of, memory stuff. You're going to hope that the engine's going to do a lot of that for you. You're kind of just going to be focusing on behavior, making things move, changing colors of things, checking for interactions and stuff like that. Just focusing on behavior, not having to worry about, calculating collisions and stuff like that. There'll be kind of an API or methods that you'll use for that, being like, does this object and this object, are they intersecting? Are they colliding? All that kind of stuff.
I'm just going to stick my butt in here for a little second and say, when I was getting into game programming, I was attracted to aspects of it. There were certain things that I really wanted to do more than other things. And as we all know, our interests and our drives towards wanting to learn something it's key towards actually learning it. So maybe we can look at, say I wanted to do video programming, I wanted to do AI, I wanted to do engine, and maybe go over a couple of the key areas that people would normally be split into for where you start if you want to learn this.
Yeah, we can do that. I think we can expand a bit on what's different and then kind of dive into some of those topics as well. And maybe some people in the chat can come in, ask some questions, or maybe ask for a topic. I mean, someone's curious about AI and stuff like that, or maybe they have some other aspects of game development they want to maybe an example to, and we can pull this up. But yeah, I think that's definitely a good idea. I'm just going to add some notes here real quick saying, whoops.
Okay, while Sudo's adding those notes, I'm just going to quickly add in here. Don't be afraid to ask questions, ever. We've never mocked someone for a question yet. We never will. We get people of all skill levels in here, and we want people of all skill levels in here. There's no such thing as a dumb question. If you truly don't know it, ask, and we're happy to help you. If it's too basic and it's going to take a long time to describe, maybe we'll say join the Discord and we'll walk you through it there. But never feel hesitant to ask us a question.
Because we all had to start somewhere. And honestly, my start to programming was, I'm going to figure this out. I don't know, like, I have no education in programming. I just started doing it, and it turns out I liked it. So the way that I picked things up was very much trial and error. You make a lot of mistakes. A lot. Like, mistakes are the number one way to grow. You make a lot of mistakes. Or if you're, smarter, more classroom focused, more academic focused than I am, check out resources, check out the game programming patterns, check out some different tutorials. There's a bunch of different Git repos out there that just have lists and lists of books for you to go check out based on different aspects of game programming. The people who are into game programming are extremely passionate about it, and they want to share that passion with others.
It's a great community. It's quite fantastic, especially if you start going to meetups. There's usually, depending on where you live, there should be a pretty prominent local game dev indie scene. And at least the one here in Vancouver that I've gone to has always been incredibly welcoming, and it's just fantastic to go to because everyone is just so passionate about this field. It's not something I've really seen in other kind of areas of programming. People are very passionate about this, and it helps with the motivation. If you're feeling kind of stuck or you're feeling a bit demotivated when you're trying to learn, I highly suggest, reaching out to a community or finding a community of people, because support will go a whole long way.
So I popped a link in. If you are academic focused and you want a classroom structure, hit gameinstitute.com. It is the best resource I have ever found yet. I've looked at more than a few, and it is the best that I have seen. Also, one of the first I found, luckily, so it really helped me get into it. But yeah, I've looked at a lot since then, and it is fantastic. It goes over all the areas of programming, Pookie. So, I know very little about programming, wondering what are the main types of programmers needed for a basic game. To put it down to simplest terms, you need your foundation programmer, structural programmer, which gets all the framework and like how different parts of the application talk to each other, and probably going to be responsible for like the engine side of stuff, which is probably going to be done by an engine if it's a little team, but that would be your physics and collision and all those like core pieces. Then you're going to have a behavioral programmer that does all your AI and stuff like that on that level, all the scripting and the game interaction. And then you're going to have a graphic programmer, which it's going to be more graphics, but there is a programming level to that of importing all those vertices from that model into the application to be read and drawn in the game world and mounted with the animation and all those fun things.
And there's another level here that is often forgotten and often well, I guess forgotten is really the best word for it. The UI programmer, the person who makes sure that the UI actually functions, runs well, doesn't impact the rest of the game, and relays information well to the player.
I forgot the UI programmer.
Like I said, forgotten.
I paste in some of the types here, just kind of briefly go over them. But yeah, as Dave said, you'll usually have the game behavior mechanics, and most smaller teams will be kind of working with engines. And actually, even larger teams now will be working with engines. They just won't kind of be in-house engines. But when you get to a larger team, those actual developers get kind of separated. Their engine and tools development aren't actually too involved with actual game making. At least depending on the project and the size and all that stuff. They kind of are just building the tools and the framework that the game developers use to make the game. And that kind of just goes to show how different game development can actually be from traditional programming means. It is kind of just its own beast, and engines and other supporting tools are just, in fact, that they are just tools. Game engine programmers, depending on what side they are, they will be closer to game developers. If you're doing like graphics programming and AI logic and all that kind of behavior, you're going to be a lot more involved with it. But if you're doing things like map editing tools, design tools, scripting, all that kind of stuff, and QE automation. My God, words are hard today.
Automation. There you go.
There we go. Thank you. They're all part of the team, but they can be kind of separated. But if you're to make the core of a game or what's kind of needed for a game, and most of the time these programmers will have experience in all of this, and they'll kind of will wear these hats at different times. They don't really get kind of locked into saying I am just the game behavior mechanics, or I am just the UI engineer. If you get to larger teams and AAA studios, they'll typically hire someone for just that role, because they're going to be very good at that role and very specialized, and they don't need someone to move around too much. But for smaller teams, and especially if you're getting out and trying to learn game programming yourself, you're going to be learning kind of all of these different topics. You're going to be learning UI engineer, because for your game you're going to need buttons and menus, and you're going to have the player be able to start the game in some way, or pause it, or be able to interact with the menu. And that is something a lot of people take for granted, that it's a art and a science, and more so I'd even say kind of on the art side. It's a lot of it is feel. You can't really write a full guideline that just says this is the perfect UI and how it is. It's very kind of conditional, and it'll change a lot depending on what their overall use cases is and kind of what's there. And then game behavior mechanics, this is kind of a lot of the actual game scripting. This is things you'll see for combat, to boss design, to say if it's a driving game, how the car moves and feels. Can it drift? When does it drift? How fast is it really moving? How realistic are we going to do it? Is it going to be a full sim where we're going to take into a fact engine and wheel torque and all that stuff, or are we just going to apply a physics force onto the back of the car that just moves it in a direction we want to go, and kind of have it be a bit more arcadey when it hits something, and we can tune the acceleration to not have to be compensating for engine power. It can just be a 0 to 100 force all of a sudden in an instant, because it's a game. It doesn't have to be realistic,
or it's an electric engine.
Yeah. And then same with like AI programming. This one is a very complicated topic, but it can also be kind of very simplistic as well. And this is a lot of kind of logic-based stuff. When you're an AI programmer, you're kind of figuring out enemy behaviors as well as even just companion behaviors of the game objects that are kind of going around. And it can be other things as well, as sometimes games will have a bit of a hidden AI. Maybe there's a kind of a curator to the experience, and we've seen things like this in games like Left 4 Dead, where depending on the current player's style, it'll adjust the game accordingly. If the players are doing very well and they're very aggressive, it's going to start throwing more and more hordes at them. Or if the players are taking their time and not doing anything, it kind of determines when certain things happen. It adds for a bit of dynamic play, as well as kind of just kind of balance some things as well as the actual behavior of the enemies themselves. How are they going to path? Are they going to go right to the player? Are they going to kind of take their time? Are they going to try to dodge the headshots that the players are landing? Are they going to run in a straight line? Are they going to ambush? Are they going to wait around corners? There's a lot of it that kind of goes into that, and it's kind of also boils down to art, and it's the kind of feel of how it is too. If the enemies are always acting to behave, if they always are just running at you, it's going to feel different than if the enemies are also always just going to be waiting around corners and ambushing you. And that's why you kind of see a mix up in that. And then as well for engine programmer, this will be kind of the people who are very well versed in the engine itself, whether it be an engine they wrote themselves because it's a homebrew thing for a small team, or even like a larger team for something Ubisoft Snowdrop, or if it's something like Unreal and Unity. There are a lot of developers out there that have had access to source. Unreal is open source, so there's a lot of developers out there who know that engine inside and out and have a lot of optimization knowledge. And you'll get to a point with games, especially 3D games, where you need those optimizations, and you need someone who's familiar with the engine that can go in and figure out what's kind of going wrong and what approaches you have that need to be tweaked or changed to have your game run at the optimal performance that it needs.
Which is an incredibly difficult job. So for anybody who isn't aware, 60 frames per second means you have 16.667 milliseconds in order to update all of the game logic. All of it. All of it.
And write that information to the buffer.
Yes. Very, 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 very difficult. Requires a lot of optimization, and it's one of the reasons why we love to shout out Doom Eternal, because that game will run at 300 FPS on a potato.
It hit 500 FPS on ultra settings on my system. During gameplay. Without dipping during action.
I'm surprised it's getting DLSS. It's gonna be. It was like the one game that probably didn't need it, but I'm kind of amazed to see like how far that game can get pushed.
The interesting thing to me is it's apparently a Vulkan implementation of DLSS, which means that it's probably also compatible, or will be compatible with the Radeon alternative as well.
That's really interesting.
I also heard that there are going to be some Linux implementations of that as well. So with the Vulkan implementation, it kind of opens things up for DLSS to run on Linux, which is great because I really would like to see Linux become more and more, available for gaming. I'm tired of Windows for gaming. I don't want to have to be locked into this. I'd like to have that choice because, competition is good. It would then force Windows to maybe make the gaming environment for Windows, improve it as well because it's
competition is a good thing there.
Yeah.
Hello, Rubino. Sorry, I just didn't want to interrupt people while they were rambling.
Also, Vulkan ray tracing.
Yeah. Anyway, that's programmer types, but maybe we could quickly go over just for everybody's sake.
Rubito has a question.
Yeah, man, spit it out. While you're asking your question, I'm going to quickly let's go over basically what Godot or Godot.
It's Godot, I believe, but I'm not.
I just pick one.
Yeah, it doesn't matter.
most tutorials call it Godot, so I'm just going off that, and that's what I assume. But I haven't found an authority on it. But yeah, Godot.
Yeah, so make a choice.
The website doesn't tell you how to pronounce it.
To put into basic scientific context of what really has to actually happen in that 16 milliseconds, and why does all of that have to happen in 16 milliseconds to get those frames? Right? Because in order to draw the next frame, before it can draw the next frame for where the objects are in the world, it needs to know what has happened in that time. It needs to know if something's been hit to know if it needs to draw a hit effect, right? It needs to know if two objects have collided to, draw them in going in a new direction. Things like this. I can't just assume and automatically go in that way. So all of your physics needs to be understood before the next scene can even begin to draw. And your physics need to be ahead of your frames.
Yeah, you'll see a lot of games now. They'll multi-thread this process, and physics calculations and all this other stuff happen separately from the render. But if it's not keeping up to the render timing and your frame pacing, the experience still isn't going to be great because things are just going to look weird. Sure, the game might be smooth, but all of a sudden, if your calculations for physics are slowing down your gameplay, either the game's going to feel like it's slow, or you're going to start getting into some kind of undefined behavior because you're going to start missing a few collisions.
Your game's going to do a physic.
Yeah, you're going to get a lot of input and a lot of things going on, and you can't just, because traditionally with the traditional programming, you kind of will have some leeway. Well, you'll be like, okay, well, we'll build a stack or a queue, and we can process things, and get to them eventually. And sure, things will slow down a bit, but maybe we'll throw more hardware at it and get through it. But you can't do that for your games. You'll hit a point where if you're not hitting the time it needs to calculate, you kind of just have to move on and move forward and discard. And that's when you get a physic, because you're hitting a wall and you're like, screw it, we'll carry on the next couple frames. But depending on how many frames you're missing in the calculation, if you get further enough through a wall where all of a sudden you're not colliding with this side of the wall, you're now technically colliding with the other side, and it thinks you're supposed to be in this side, that's when you start shooting through the walls or falling through the floor and all that kind of stuff. That's kind of how that happens. And it's because if we were to try to lock and figure out those calculations every frame, the games would be unplayable. It's honestly even fascinating that we have the physics sandbox that we have, and they even function the way they do, because there is a lot that can go wrong, and a lot of it isn't a sure thing. It's kind of just like, yeah, it should work. We'll see what happens. Just don't do too much stuff at a time, or please don't take an object with a lot of edges and put it into a corner so it collides with all three walls at the same time.
This is definitely something we should address and talk about right now, because I hear a lot of people, like a lot of people that do programming but have never done game programming, they don't get it. And when they see bad physics in a game, they're just like, well, we know what physics are, why can't you get it right?
Because it turns out those calculations are extremely complicated and very expensive.
It's a really interesting topic too, and I'm glad Dave's addressed that, because game physics and real physics are actually very different things now, or actually always have been. They just out of necessity. We can't, in a perfect world, we know the physics. We could just make a full physics simulation of everything going on and just put the objects in and have them run, which is kind of how a lot of 3D modeling and 3D rendering goes. But then you'll see that their render times are in the months.
I was going to say that you get, a handful of frames a year.
So what's happening now is that we have to approximate, and we have to kind of write pseudo physics. So everything that's in physics is actually just everything in video games is actually just a pseudo version of the actual realism itself. Even
most of the way there.
The big holdback here, and the biggest problem is processors do some math really, really well. They don't do all math really, really well. If you're asking them to add, subtract, multiply, divide, great! Let's do that!
Super fast.
Yeah, they love that. If you send them, like, the square root of a number, they're gonna go, yeah, no.
Which is why fast approximate square root is a thing, and John Carmack is a fucking genius.
Yes, but yeah, like if you wanted a nice smooth sine wave to dictate how your strobe light is gonna look super awesome in this scene, you're gonna get a couple frames a minute. That's just what you're gonna get out of it. So you have to do lots of really, really interesting stuff. For all the wave functionality, I can go into. Do you want to save it? Are we going to do a math section?
We'll probably do it a math section.
We'll do a math section because it's more. There's a lot to talk about there.
Yeah, wanting to get into game programming kind of determines like what you want to do and on what level. And at the very high level, a lot of this stuff will be handled for you. But as you kind of want to get more into the nitty gritty and get more control, then there's going to be more and more things that you'll have to be aware of and have an understanding of. And math is going to be kind of the biggest one. That's kind of the beauty of using a game engine, is that there's going to be a math library put into that. And the most of knowledge you're going to have is just knowing the names of a function.
If you have to do math, use the library. Don't do it yourself. Use the library. Do not do it yourself. Okay, done.
The library may be infinitesimally slower. It may be a little bit slower, but it's tested and proven, and you know how it's going to behave.
Math libraries are a lot of work. I have gone through what I would like to write one, and it's just use the libraries, but even just then, it's also just, knowing what to use in the library, because at that point, it's just, depending on how abstract the framework is, and this is kind of another point of, when you use an engine, it'll have a math library that it probably won't even expose to you. It might hide a lot of the kind of lower level functionality, like the calculus functions that might hide. So when you want to rotate an object, you're just going to have rotate, and it'll probably just take in, what axis do you want to rotate on and how many degrees. Whereas, math library functions, you'll be getting matrix transform, and you're gonna have to pass in an identity matrix as well as your rotation matrix to figure out how much you want to do that. So thankfully game engines are like, oh, you want to turn this thing 90 degrees on the x-axis, you just do this, or a lot of times it's kind of just vectors. You'll probably need to know vectors, at least like understand kind of what vectors are, but you won't have to understand vector calculus to move a thing in a game. And most tutorials will help you with this too, and most things are going to be like, if you want to move an object, there'll probably be a function called move on it, and you just pass in a vector, which will be, the direction you want to move it into and the magnitude, how much you want to move it in right now. Same with, doing intersections and doing collisions is going to just kind of just be like a, intersects or a collides, and you get to put in your objects, and the engine will just figure that out to see if they're colliding or not. All that kind of stuff. But then we kind of want to go into optimizations or do a bit more kind of fancier, trickier stuff. You will then have to dive into the maths, and it's not big and scary. A lot of people say you don't need to have like a master's or a PhD to do game programming math. It's
just very different. Very different.
Yeah, it's like calculus, and like calculus can be complicated, and a lot of people didn't or struggle with calculus in high school and maybe even post-secondary, and as soon as they hear that you need calculus for game programming, they're like, well, I can't do it, I'm messed up. Give it a try, because it's a lot different to learn calculus when you're just doing practice problems from a book that don't mean anything versus doing calculus when it's your game and you're trying to do something interaction. It's really cool, and you'll kind of get a new understanding and appreciation for math when you get to use it to make something move on your computer, make a ball roll around, or make a car move, or rotate a box. You kind of have a really good understanding of actually what the math is doing, as well as some really cool practical applications for it, and you'll find more motivation. It'll kind of kick you forward to keep going through with it.
Just keep plugging Game Institute.
They're so good. They're so good.
It's something that I struggled with as well, and it's the reason why I didn't go through the traditional education system to learn programming. Is I don't do well in a classroom environment. I am all about application. I need to see what it does. I need to do the thing. So, I mean, I totally understand that a lot of people would struggle with trying to learn these things in an abstract manner. And I highly encourage you to just do it. Just go do the thing. Math is actually amazing. I hated math when I was in school. I was wrong. Math is amazing.
Yeah, I dropped out of Math 12 as well because I had one of those teachers that couldn't conceptualize things. Like I asked, why does this equation make this graph? And the answer is because that equation makes that graph. That doesn't help.
The best analogy I've seen for it is that, the way that math is taught in high school would be like teaching an art class or a painting class, but all you do is paint a fence.
Yeah.
It's very dry. You don't really get to see the full applications of it. You're kind of like, well, am I ever really going to be, painting a fence? What's the point? I've heard so many people say, what's the point of algebra? Am I ever going to use this? And it's like, yeah, actually, if you got exposed to a bit more things, algebra is very useful. It's a problem-solving technique, right? It's, you're trying to find a solution for X. X doesn't have to be this arbitrary number that just gets thrown in. There's lots of practical applications for this, especially if you're trying to calculate budgets or do anything like that. It doesn't have to be this terrible thing.
And like that functional math. Oh, love functional math.
Yeah, but it's unfortunate because, like I said, most people, it'd be like teaching a painting course and only painting a fence and having just one color. It's going to be nothing exciting, right? And there's a whole world out there for what it is, but it's just misunderstood because they're just teaching the very basic of it. So you just have some exposure to it, but a lot of the times it kind of does a lot more damage than good because people feel like they can't just do math. And it's one of those things where, similar to art too, is I don't think that there's people who just can't do it. I think it's just you need to find different approaches to it. I was one of those people who thought I could never do art. I thought, oh, my brain just isn't an art brain. I've done one of programming. I can't do art. But then I found using Blender and 3D modeling, all of the stuff was a different approach. I no longer have to have a steady hand. I could never color in the lines. I could never draw a straight line. But I can get a computer to do that for me. And now it's just, going into a computer, and it's kind of more on the programming side. I'm more kind of programming art. I'm telling this system what I want it to do. I'm, putting in timings and rotations and all those other kind of stuff. And it works for me. I can apply textures. I can adjust lights. I can do all this other stuff that doesn't require that. It just requires a bit of playing around and having fun. And it was something that I, turned off for a long time. But I think that you can still explore things. Don't knock them until you try them, kind of an idea. And I think the same thing goes to game programming. If you haven't tried it, if you're new to programming, or if you're programming for a different medium, even if it's like a full stack developer, or maybe even you're just like a WordPress developer, from anything, just give it a shot. It's not as hard as people think, and it's very enjoyable, and it's very, very rewarding when you've made something that you can play, as well as you made something that people can play. It's a very satisfying thing to have someone interact with the thing that you've made and have fun.
Yeah, that would be.
That's why I'm a UI developer.
I get that. I could see enjoying being a UI developer as well.
I like to make things for people to use. Doesn't really matter what that use case is. If it's, other developers who are going to be writing code with a library I built, or if it's, people pressing buttons on a screen and they go, oh, wow, that actually worked really well. I like that. That brings me a lot of satisfaction.
It's okay. Words are hard today. Words are just hard today. It's one of those days.
Yeah, it's just something about this day, something in the air. It's making words not good, not work well.
Not word good today.
Yeah, to touch on what we said before about the different patterns. So game programming patterns are quite a bit different from something you'd see in things like web development or traditional kind of OOP or object-oriented programming approaches to software solutions. And what kind of might seem like a code smell, which is a term for saying, your code has issues with it, or, this is kind of bad practice or bad design, are actually pretty commonplace in game programming and especially game scripting.
It makes me so mad.
A good example of this, which I'll post a link in our Discord here for maybe in a sec we can.
But rules of the stream rage. You can't just complain about it. You got to improve it if you want to complain about it. How do you do it better?
Use the flux system and be functional.
But doesn't that slow it down?
Not if you do it right.
Unfortunately for games, you get so restricted. But yeah, so you'll see a lot of stuff because a lot of what games now use, especially depending on the engine you're using, you're going to kind of locked into their methods. So if you're using Unity, you're going to be using the entity component system. And if that's the case, most of your files are going to kind of have to contain what they're going to be using and kind of what is relevant to them. Because when you're going to be accessing that from a different entity, you don't want to be going to 2 or 3 other places. You want to just get that entity and be able to use everything relevant for it there. There are patterns and methods to kind of improve that. You can use something called managers. We'll manage all those kind of entity objects below, and you can use that as a kind of optimized solution to access things you need. But for the most part, what's going to happen is you're going to have your game object, let's say it's player, and in player or character, you're going to have everything that's relevant for the character to do its things, and then anything that another entity needs to base their state or behavior off of will need to access that. And you won't really be going to player and then player behavior or player car or player weapon or player. It'll all kind of just be in one thing. But then what you're going to see is these huge files, especially files with a whole lot of variables at the top. It is very common in game programming to see files that have 100+ variables at the start. And for people who are used to other methods of programming, that's going to be the first thing you see, and you're going to be like, what the hell is this? This looks terrible, because most programming methods, you're going to be taught to abstract and reduce, that many things, especially because it's a lot of memory. But as I said before, video games are that medium that are just, give me all the memory you've got. We're going to be expected to be using 4 gigs to upwards. So having a bunch of ints, even just for basic stuff, isn't a big deal. As well as you can't have a lot of object things where a lot of times you would abstract this thing out to a separate class or a separate object. You kind of just need it all to be in this one class. So you're going to see a lot of stuff that is kind of redundant. You feel it could be somewhere else, but for a game script, it does need to be there. And an example that I like to go through is the kind of decompiled source for Stardew Valley. And in there, even just in their character controller, and there's some other files as well that have a bit more variables at the top and a bit more of a smell. And I'm not saying this is like the best or the worst for game programming. I'm just saying that
this is kind of an commonly used pattern.
Yeah, example of what to see. So I think here the first 100 and let's see the first kind of 100 lines of this file are all just variables, a bunch of which just kind of have magic number hard coding, right in them. And that's just kind of how things will be, because you won't have a lot of time to, abstract a lot of stuff. Or sometimes it's just going to be things like, engine force or character move speed. And there's going to be other places where that's going to be handled, especially if you're using an engine like Unity or Godot or Unreal. You're going to have an editor, and in that editor, you can actually tweak and change those values, even at runtime. And it's kind of, we'll get into later about game scripting and mechanics is, you're going to be a lot of look and feel, a lot of kind of tweaking and stuff like that. But to be able to do that, this game script needs to have all those variables there for you to tweak and script. You can't be, plotting a bunch of stuff onto it and going to different locations. It needs to be somewhere where the editor can grab and pull them all into. And that's things kind of just, a lot of times, move speed and just anything that your game, it really depends on the game. Like for my game, one I'm working on right now, which is like a driving game, everything to do with, the car speed, and even things to do with like camera turning speed and how how fast the car can go, how fast does it accelerate, how fast does it brake, how quick does it turn, how long does it take to get to its max turning speed, what is its max turning angle, all that kind of stuff is mostly in one file and is accessible by the editor, so that when I'm playing the game, I can have the game running and the engine running, or the engine behind it, and I can tweak those values and not have to exit and recompile. They get loaded in. That's kind of the beauty of using an engine. The downside of that is that the code looks disgusting because it's just this massive file with all this stuff. So for existing programmers out there, it feels bad, but honestly, a lot of the programming is going to feel kind of bad. You just gotta get through it.
You just gotta do it.
Don't worry.
Just let it happen. Just let it happen.
Especially at first, just start doing it. Don't worry. Another pitfall that can kind of happen is you'll worry about optimization, because that's going to be the first thing. You're like, this looks like, you're going to go through tutorials, and your first assumption is going to be, well, this is a basic tutorial, so they don't care. I have some understanding, so I'm going to try to make this a bit better, which is a good approach. But just make sure to do their approach first and then try to optimize. Don't try to optimize before doing their basic approach first. The reason for that is you might notice that you get their approach running and it runs fine, but then you try to abstract yours to new files and you start running into issues either with just access, like being able to access the data you need, versus also just maybe a performance hit. You're going to see a lot of kind of gross and weird stuff, and you're like, well, this is not typically what we do, and it's kind of going to be there just for optimization. There's a lot of patterns that just won't be able to be applied anymore, especially when it comes to things like arrays and data and calculations. You'll see a whole lot of lookup tables, and for people who don't really know what a lookup table is what will typically happen is a lot of calculations will be done beforehand, and they'll get put into an area, and then what's going to happen is, instead of if you're going to run a for loop and go through and calculate a bunch of stuff, it's going to take too long. So what's going to happen is, when you're iterating through all your objects, they're just going to go to a lookup table and grab either the value that was calculated before or pre-calculated somewhere, but they're not really going to be calculating at runtime too much. It might be happening on kind of like a separate thread and just populating that table, and hopefully it's there in time. It just feels like a terrible approach, because it's like, well, sometimes it might not be. It feels like an edge case we should handle, but you just can't sacrifice the performance to make sure that that's the case every single time.
Yeah, and knowing where to make that cutoff is very important. As a non-game programmer, my instinct is to always make things as easy to read, as easy to understand, and as easy to maintain as possible. But in game programming, your performance is king. You absolutely have to have that performance. So a lot of the time you end up with code that most people would consider unreadable, and there has to be a better way to do this. And I absolutely think there has to be a better way to do that. But it is what it is, and that's what you need to do to achieve the performance that you need.
Yeah. Yeah. There might be a better way to do it, and there probably is. We just haven't found it yet. Every once in a while we do make a breakthrough.
Yeah, and even then, too, a lot of these indie games, you'll see a lot of this stuff, and a lot of it can be improved with just kind of simple software patterns. But there's also the whole, a big thing for games is, scope management and time management. They do take quite a bit of time, and a lot of game development isn't actually too much programming. It's really going to be tweaking values and testing values, which is why you're going to what you're going to really see is a really basic implementation or really kind of gross script for a character. But then that'll probably take 5 hours something to implement, but then you'll see 20 to 30 to 50 to even 100 hours of actual time logged in just tweaking the values that are there. Like if for the game I'm working right now, I said it was a car driving game. I worked on it for a couple months and then took a hiatus for school. And then lately I've been going back into it, and my camera script and my car script, I have a basic prototype made, and I'm not going any further until I have the cars and cameras feeling right. And I've been another, 2 months into it, and I can spend 8 hours and I can make zero progress just because it's not feeling right. I can spend, 2 hours and make a bit of progress. It's one of those things where you're not going to know. And I could spend a lot of time optimizing my scripts, but my time for now needs to be getting those values right. It's not always the actual code and performance. It can also just be, how does this feel? And that's kind of another big part of game scripting is you're not really going to be programming in the sense of, it's not going to be so clear what your end goal is.
Yeah, that's why you play so many games and you go, oh, this camera feels like garbage. Why doesn't this camera work right? And it's because to make a camera feel right, it takes a lot of hours. It's very expensive because for a professional game, you're paying proper developers who earn a considerable salary for all the hours that they're putting into tweaking and tuning these variables to make that game feel right.
And game developers are tragically underpaid.
Yeah, it's one of those things where it's passion. So you can, if you're going for this professionally, and this is something that I do as a hobby, if you're going for game development professionally, you'll notice that because of that passion, a lot of people are willing to take a significant salary hit to do this because it's something they enjoy. And, it makes sense. It's just unfortunate that it kind of leads to a lot of, exploitation. And you hear a lot of things about crunch time. All of a sudden people are working 70 hours a week. Because they enjoy it, but then they also have to realize that you should still have a life, outside of this, and there does need to be a work-life balance, and that it is, a job. This is one of the reasons why I kind of prefer doing it as a hobby. I'd love to do it professionally, and maybe someday, but it's the industry is at a point right now where it can be kind of, you have to be kind of careful. Like if you're not to be exploited, but just in general of just how kind of competitive it is, at least, as well as just the kind of pressures that go into it. I'm doing it for fun. I want to make sure that it remains fun. I don't want to, get jaded and burnt out and all of a sudden, lose a hobby that I've enjoyed for a good majority of my life.
And there are companies out there that do take good care of their game programmers. Skybox Labs in Vancouver is one of them. But they are unfortunately few and far between.
The industry the same in Japan.
It's even more exploitative.
Yeah,
it's really bad over there. I've heard some unfortunate things, especially like competitive salaries are even like really low for game developers there.
Yeah. But at the same time, if you have people coming and going, I'll work for less than him, please give me a job, do you say no to the guy?
Yeah, the work culture overall there is unfortunately not very great. They're like outside of even the game industry, it's even just like software world there in general is quite brutal. Those hours are very long, and they work very, very hard, and it's unfortunately it's just a part of the culture for how things are. But I'm really hoping that as things go, things can kind of grow and change because it's not really sustainable, and I think they're seeing that with just the magnitude of how many people are burning out. It's kind of, I think it's on average like 5 years. Even for like Western studios, they're finding that a lot of the people that are working these crunch jobs, your lifespan for that is about 5 years, which really kind of sucks because they can't really transition to many other places at that point, depending on what their opportunities are without experiencing that crunch. So they kind of have to leave the industry, and that's just very unfortunate because some of these people are very, very talented people. It's just the companies are exploited that and didn't think of them as people. They just kind of use them as just a workhorse, and then when the workhorse was done, they move on and got a new one.
Yeah. Hey Talesha, welcome.
There have been several experiments done by very large companies, because generally they're the ones who can afford to do these experiments, but for instance Microsoft Japan experimented with a 4-day work week, and they saw a huge increase in productivity. Like this 80-hour work week, this crunch until these people burn out and become just husks of themselves, it doesn't get you anything.
It does for a couple weeks. All it does
is hurt people.
Yeah. So be careful, but it is a fun place to work. They do provide a lot of fun stuff and whatnot. There's many perks, and that's why people keep going there.
Yeah. So yes, for game programming, like I've been saying a few times, ideally at the start, you're going to want to offload all the work for programming the game, most of the game onto engine itself, or find an engine that'll kind of take as much as it is, so you can kind of focus on behavior inputting. Because as I was saying before, the look and feel of the game is kind of the meat and potatoes. You can have super optimized code for input or super optimized code for collision stuff. None of that will matter if your game doesn't feel right, and that all just comes down to script programming. And it's such subtle things as how fast does your character move? Is there acceleration? Is there deacceleration? Do they slide? Do they snap to an edge? For car driving that I'm dealing with it now is how fast should they be able to turn? And it's one of those things where no one really seems to get it right. The closest one that I've really seen that feel really good outside of like racing games, just like open world games, is like the Grand Theft Auto series. The cars feel pretty good in that, but then you'll play something like, like
Just Cause 2 or 3. Just Cause 3. Just Cause 3 was the one.
Watch Dogs, all that stuff. They just don't feel right. Like they function and they move, but something about them, it's not as as fun as an experience. You couldn't just drive around just for fun for a lot of times. It's kind of there, but it and all of that. It's not to say that their code was bad. It's just to find those settings, to find that the tweaking that's there is a whole lot of effort and takes so much time. And it's also comes down to a lot of preference too. And even, a lot of people will still prefer those to, I'm sure there's people that prefer, the driving and Watch Dogs to the driving and GTA and stuff like that. So you can't even just please everybody in that sense. Anyways, you kind of have to find what you're going for and what's going to kind of suit your game as well. And that's where a kind of arcade racing comes in versus, you'll have a game kind of like Project Cars where it'll be more on the simulation and more on the realism side versus something like Need for Speed, which is, classic, just arcade. You're going to go fast. We're not really going to care too much about what should be realistic or what really be going on. We're just going to care about fun. You can turn on a dime, you can crash and it's not going to matter. You can bump into things and you won't lose all of your momentum. You can accelerate to unheard of levels without your car just falling apart or spinning out or smacking the wall. One thing I found when I first got that driving setup is I kept doing pedal to the metal and my car would just spin and hit the wall because wheels weren't getting traction.
Yeah, that's how cars work.
Unless you have a Honda or something like that, then you can just floor it and go, and it's fine. It drives like a game.
Yeah, because I was used to arcade racing games and stuff like that, and I hop in this thing, and I think it was like a Mustang or something, and I hit the floor way down, and it's just spinning, and I'm like, oh god, what is happening? And you'll change a gear and all of that other stuff, and that stuff is good and fun. That's the point of it. But I'm saying there's a huge difference in games and look and feel for different audiences. And when you're first getting to game programming, that's what you're going to want to focus on, is kind of learning those mechanics and learning those behaviors and learning how to make a game feel good, rather than worrying about how to make it kind of run good at first.
The first time you try to make a basic platformer and you start programming the collision with the platforms and the movement of the character and jumping back and forth between platforms, and you do it for like 8 hours without realizing it, and you made it feel kind of better, but you gain an instant and sudden respect for all of those old school platformers that you've played that felt so sharp and good. You're like, oh my god, that must have been so much work. I remember the first time I wrote a platformer, instant respect for all of the previous platformers I had played. Oh my god.
You go and play something like Super Meat Boy, and you're just like, wow, this is tight. Or you go and play something like Hollow Knight.
Yeah.
Like, these are very tight controls, and you've been trying to replicate them. And it's good to have that exposure because you can go and try and replicate that and see what's there. And it's a lot of just subtleties. There's a lot of kind of stuff that goes into it. And just implementing basic platformer, you'll be like, oh, this feels weird. And even looking back at like the NES days, look at how well Mario handled, and that was a platformer. Then look at how many other platformer games there are. Pick up any LGN platformer and try and play it, and you're like, I can't. This game is, I can't hit these platforms. I can't move. It just feels so wrong. And it's not like it was some hidden secret or anything. They all had access to the same stuff. It was just how much effort, how much time it really takes to get that feeling and get that smooth control into a game.
That's the word you always hear us talking about. Polish. The time spent perfecting those little pieces that are so important. Movement shouldn't be a little piece. That's the core of your game. Get it right. Elevators. Ladders.
Elevators are hard.
Ladders is what made me rage quit my first game. And I want to talk about this. This is important too.
Yeah, go for it. I'm going to close the window behind me a bit because the light leaking in is just killing my white balance.
No worries. I'm just I have going through my notes here. So another important thing is that it's going to be closer to functional programming, but it's not really going to be as complicated as what you'll see with diving into something like Haskell or anything like that. You're not going to be dealing with any of those crazy terminologies I won't even bother bringing up. I don't want someone to ask me to explain because I don't know. I'm in the ballpark that I don't think anybody knows. We just keep moving on with it. It's like I keep seeing the definitions. But yeah, whether you're an experienced programmer or you're new to game programming, you're going to be very ambitious because you're going to be very exciting because, you know, this is your passion. You love video games and you want to make them. You're going to be over ambitious in your first title. This is what's going to happen with everyone. It happened with me. You know, no one is going to go into it planning small because what's the point, right? That's not very exciting. But you're going to have to do it. You're going to have to try and, you know, force yourself to do the small stuff first before getting to your big idea. I still say don't give up in your big idea. I would look back at our other talks where we went over a game design document, and those should take, you know, there's no time limit on how long that should take. I think if you have a big game idea in your head and you want to make it awesome, start a game development document somewhere you can access it and chip away at it here and there. Start making smaller titles and take what you learn from that and apply it to your game development document. Because in there you'll be going through design and, you know, approaches to things, and you'll find things that aren't going to work for you. Because a lot of people, you know, they're going to want to make, you know, and like I've seen a lot of people who just want to make an MMO right out of the gate, and there's no way that a small team can make an MMO. But it is possible for a small team to make co-op games, and you can make an 8-player co-op game. It's not easy, but it's possible. I mean, Valheim is a recent
Valheim is
example,
exactly what I was thinking of.
It's a fairly small team. You know, they could have tried to go with the MMO approach and had this massive server architecture, and that game would be super sick as an MMO. But that level of knowledge and that level of programming needed would be way too big, and that project probably would end up failing. I don't even know if Unity could even really support that out of the box. You would need so much for that. So try to start small, and smaller the better, because it's easier to build yourself up than to kind of tackle something very big at the start. You'll eventually start getting comfortable. It's one of those things where you don't know what you need to learn, so you feel like you can kind of do everything. And imposter syndrome is very, very common in software development, and it's very healthy to kind of have a bit of it for when you're getting into game programming, at least, because as much as you don't want to, you know, feel like you can't do anything, you also don't want to feel like you can do everything, because you're going to be over ambitious, and scope is the #1 killer of games.
If you've been listening to this channel for any amount of time, you've heard us drill it into your heads by now. Scope, 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 scope. Give yourself time to polish.
It is very, very important. Start small. You can always add more later, but be careful when you add more. It can get out of hand very quick. And as I was saying before, most of the programming is going to be tweaking values and variables to get things to behave and feel right. And for experienced programmers, it'll be easier than you thought. When you first dive into doing tutorials, like, oh, this is easy. This is, you know, fairly straightforward. I want to make a thing move left or right. I just make it move left or right. I can make it move up and down. I can plan out all my behavior I want. Programming it is easy. The process is easy, but making it feel right is going to be very, very hard. And that's where things can get kind of frustrating, because there isn't a clear tutorial on how to make things feel good, because that changes from every game to game and is preference, and you'll have to be very careful with that. It is very important, I guess, to start small. A good example for what I like to suggest to people is to, of course, use an engine, but also start in 2D and start cloning arcade classics. Things like Asteroids,
Pac-Man,
Pong, Pac-Man, Snake, all this kind of stuff.
Snake's
There's a million tutorials out there for them. And the more basic at first, the better, because the more basic the original game is, the more room there is for you to add improvements to it and add flavor and add some extra spice.
Add sauce. For example, yeah. That's why we use the sauce and meat and potatoes reference all the time, because it doesn't matter how much sauce you add to a meal. If you didn't get the meat and potatoes right, it's not going to be good.
Yeah, so I'm going to... Whoops. My clipboard didn't work there for a second. We're going to let's talk about kind of like, oh, how should I program games, or how should you kind of transition into programming games. And as we were saying, it kind of depends on your skill set and kind of the goal of your game and how comfortable you're going to be with various languages. As a blanket kind of recommendation, I can say Unity. I've used it a fair bit myself. I prefer Godot currently, and that's just because the ecosystem for it is just something that I like a bit more. I like being able to kind of view the source of things, and a bit of the kind of challenge it brings with it, as well as it's just kind of new. But for recommendations, I'd say, you know, Unity. Unreal's a good one too with blueprints, but Unreal for scripting uses C++, and depending on where your knowledge is, if you're not comfortable with C++, if you're a C++ programmer currently, I'd say, you know, go ahead and dive into Unreal. There's a lot of things that can help you with that. But if you're new to programming or coming from like a web dev area, I would say start with Unity. A lot of tutorials, great community, and it kind of will really help you ease into it. And along with that, as I was saying, for a good start, clone arcade classics. Like we were saying Snake Pong, Asteroids, and there's tons of tutorials that give you great exposure to the game engine. So you know what the game is, you know what you're going for. There's kind of an end goal in mind. You're not a lot of uncertainties, because those uncertainties is what allows scope creep to happen and allow you to kind of infinitely tweak something. You know how Asteroids feels, you know how Pac-Man feels, you know how Snake behaves. You can clone those pretty close because you have an actual version. You can pull up Pac-Man in a web and play it and kind of compare it directly. There's an actual case to use and to compare to. But as we also just said, there is lots of room for improvements. And some examples I put for Asteroids, you could have enemy ships that come in and try to attack the player, and the player has to dodge and shoot them. You can have ship upgrades, so maybe the ship gets bigger, the ship gets different weapons, maybe the ship gets a shield, all that sort of stuff. You can add other different kind of mechanics like refueling. Maybe the ship can only be out for so long and has to get to a point to refuel. There's so much stuff you can do, and that's kind of where the motivation for game programming will come from. You can learn the basics by cloning the basic titles, and then once you get a bit of understanding, you use that knowledge to really expand, and you'll get that motivation of, oh, I can do this, or oh, I can do that, and let your creativity flow, and that'll carry on to learning the other aspects of game engines that weren't included in the tutorial, but aren't too far away that will be overwhelming.
For sure. Yeah, you've recommended this way a few different times, and it continues
the perfect way to be start. A good recommendation.
Yeah, it is the perfect way to start. I had never thought of it before, but yeah. I mean, why not? Why not start with the classics?
Yeah, it teaches you what you need and then gives you the room to take it and run. And it's kind of like, this may not work for everybody, and it's a bit of a more of a biased approach because this is kind of how I go about doing things. I kind of struggle in a lot of the traditional sense for schooling. I need to be able to have something to play with. I need to have something I can mess around with and tweak with to really understand what I'm doing. And that's what I've kind of liked about this approach. And that's carried me further to the games I've made. And the current game I'm working on right now, which is a driving game, my approach for this is I took an online course. It was like a Udemy course or something that was just making a basic driving and racing game in Godot. And I'm like, oh, that's kind of ideally what I want to be doing anyways. I might as well take this course. And it taught me a lot of things that, I actually didn't know, and helped me build a foundational knowledge. And then as I'm going through the course, there were so many things I wanted to try on myself or try tweaking and kind of challenge yourself. And then you can go in and do that. And then you'll hit some roadblocks there, and you can then branch out and find out what solutions to that for tutorials, because you'll find when you're game programming versus traditional programming, when you are going to Google your issue, it becomes very complicated because your game, depending on what it is going to be kind of very unique, and your behavior is going to be kind of very unique for the situation you're in, as well as people's solutions are going to be very unique to the kind of solutions that are the games that they're recommending for. So if you're going to Stack Overflow for advice on, let's say for me, for my driving game, well, I'm using Godot, which is using GScript programming or scripting language for its game. Well, if I want help, a lot of the stuff is going to pop up is going to be Unity, and it's going to be using, either C# or it's going to be using Unity specific engine features to solve the problem, which aren't going to be accessible to me. So that can be frustrating, that can be challenging. But if you have, other tutorials or something closer, if it's too big, you can just say, okay, I'll approach this later. You still have something that you can play with and kind of adjust your scope for and have a complete product.
There's another thing to call out here. Wealth of documentation is extremely important, as is quality of documentation. And it seems like Godot's got quite a good amount and quality of documentation available themselves. I just did some quick browsing on their website. But the more established engines generally have a larger community, which generally means they have more and better documentation.
Yes.
Yeah,
yes.
exactly.
Let's just squash the Unity makes bad game things, finally. It doesn't. Garbage in, garbage out. Unity is just
can actually
free.
make some incredible games.
Yeah, Unity makes some wonderful games, but because they let so many people use it, a lot of people made a lot of garbage with it who didn't know what they were doing. Trust me, if those same people used Unreal, their game would still be ass. Okay?
It would run even poorer.
Yes.
Yeah, I think most people's concerns now are kind of just like the asset flip games. But even then, there's games that do asset flip well. And it's one of those things where you won't even notice because that's kind of the point. Is the main thing about it is it comes down to style, and one thing we preach about in our reviews for style is consistent style. And when you asset flip, it's going to be a bunch of different artists with a bunch of different visions and a bunch of different styles, and they're all going to clash. And then the game, that's why these games, looks and feel so different, because there obviously no consistent style, no direction. There was no planning. They just needed something, so they grabbed it, and they tried to grab what they thought was the best at the time. And there's no way you're really going to be able to keep them coherent. But there are quite a bit of games, even AAA games. It's not like they're going to use models and then just never use them again. They have entire libraries of previous models that they keep and reuse. You like barrels, and look at Source games. And Source games reuse a whole lot of assets for their maps and their props and all that other stuff.
Or another series of games that's very core to the channel, the Souls games. For instance, you play Bloodborne, and then you play Dark Souls 3, and you go, oh, hey, there's 3 Maria fights in this game. Awesome. The behavior that you see on Abyss Watchers, on Gale, on Pontiff, very, very similar to Maria, and it's because they used a lot of the same behavior. And same with the same sort of visual effects. Like, you see a lot of Maria's, oh yeah, Sister Frida as well. You see a lot of the same effects being used. Maybe they'll be recolored, maybe they'll have, a different texture on them. But that reuse is not a bad thing.
No.
It's a good thing.
Yeah. It's and that's another asset flip is a word you hear all the time now that's just instantly negative, and it's just that some people use it wrong, and it's insane to build the wheel every single time you use it.
And don't be afraid, if you're making your game for your hobby, making yourself, don't be afraid to asset flip. Like, don't feel like you have to make everything yourself, especially if you're starting. Like my current game, I haven't made the assets in the world myself. For the most part, I've just used libraries again. I try to keep the style as close as I can, but especially for prototyping and starting off, I just want to get the game working. I can model them myself. They wouldn't be great, but I could. But then overall, I know the game wouldn't have that feel to me at the end. It kind of helps to have a bit of higher end quality assets for that to help, motivate and keep you forward. And depending on how far it goes, and depending on, the scope of your project, you can put all the models you have there and have everything ready and having the things there, and maybe they're asset flips, they don't have consistency. But if your game's getting traction, or if you have funding, you can then get an artist on board, and you have a library of everything you need. You then just get an artist to make a consistent version of them all and swap them in. You can, asset flip them out and flip in proper ones. So you don't be afraid to do that. Don't worry. If you get flack from some people calling your game an asset flip, if you're showing it off, just ignore them for now. I mean, what people are really referring to are the games that are thrown together in a weekend from, store, from the Unity store, and then sold for like $2 to $5 on Steam. And honestly, at the end of the day, that doesn't even really bother me too much, because if some people buy it and enjoy it and have fun, I'm like, who am I to judge them because the game was, easily developed? I can ignore it. I'm not too frustrated. I'm not mad that that's what someone did. Maybe that's the best of their abilities. I don't even care if they're even trying to exploit the system. It's there, and if it helps other people actually make games, then that's the kind of goal at the end of the day, is making it easier for people to make games.
It's the price of a coffee. Someone had fun. What's your problem?
Yeah. That's that. Again, on a tangent, but I've stopped measuring video games in hours played, or how quality you think the experience is, or oh, this game is too much because it costs full release price. You measure it in coffees. The coffee is generally about $5. Generally about $5. Do you get 3 coffees worth of enjoyment out of Sultan Sanctuary? I would say yes. I would say I get even more enjoyment out of something like Sultan Sanctuary or Titan Souls than I would out of 3 cups of coffee or 4 cups of coffee.
Especially if you drank them all back to back.
But the key here is that hours length of a game. How many coffees is Risk of Rain 2? Not enough. That game needs to cost more. That game's amazing. But the key here is not to judge a game based on the amount of hours that you get out of it. That doesn't make it good value. Because if it takes you 200 hours to complete the game, but it's not fun, and you would have had more fun spending that money on coffee or dinner,
then why did you spend 200 hours playing it?
That's not good value.
Yeah, no, I do tend to do that, but I also, if I'm not having fun, will just stop playing the game, and I only got this many hours out of it because I wasn't enjoying it up until that point.
Yeah, it's...
Well, the only reason people keep playing Final Fantasy 15 is because there's no friction. There's never a point in the game that makes you go, oh, and then stop and then reconsider your playing. You're constantly plodding forward because nothing can stop you. Yes, Pookie. Yes.
But yeah, anyways, to quickly wrap up this topic here, as we said before, like you don't need to have a PhD in math to do it, but the basic math concept help, especially for 2D. This is stuff that was kind of covered in high school, traversing a graph and just an X and Y axis, having understanding of moving about those, moving up and moving down. I really suggest starting off in 2D, even though, 2D is not the most exciting thing. That third dimension just really changes
makes things
up.
A lot more complicated.
Optimization wise, as well as just debugging. There's a lot of stuff that can go wrong. And when you're playing games, especially if you're coming from an experienced programmer perspective, debugging for games is going to be a lot different. And debugging is going to kind of feel what a code smell is, where, when you first start kind of programming, your debugging is just console logs, print here to see if this function's running or doing the thing you want. And it's going to be very similar to that, because you're going to have a debug view, which will just be a bunch of information you're going to write to your screen. That's going to be telling you all the state information and values of all the things going on. And that's what you're going to kind of use to debug. You can't really run a debugger with a breakpoint. There's certain things you can kind of get away with that on, but those debuggers are actually very slow. And I'm sure people who have experience with programming and even just run a server in debug mode will realize, how many more milliseconds it is to run with, debug bindings in. You can't really do that, because if you're trying to debug physics, your physics calculations are going to be way, way, way off anyways, because the system can't handle it. And if you're in 3D trying to do physics, like, good luck. You're going to have to be using debug to screen. You're going to be trying to figure out what's going wrong and identifying it. You can put in breakpoints for things like values that shouldn't be a thing, and then you want to be able to pause everything and read the stack to see what's kind of going on or how it got there. That is fine. But even just running it in that debug mode is going to be an issue. So what you'll typically want to do is do something like a variable dump. If you hit this edge case, either pause the program, put a sleep in, or put a pause in, or or dump the file to a log and then read it elsewhere, because you want to be very careful not to introduce other kind of constraints or other kind of effects to your system that will kind of throw off that thing. But yeah, 3D is kind of crazy. It will require quite a bit of math to get those things moving around. Things like rotation and collision aren't as simple anymore. So stick with 2D. Doesn't have to be for everything. If you breeze straight through it, a couple of weeks, then move up into something like 3D if you want. But just be careful, because one thing that can happen is if you overwhelm yourself, it's very easy to get discouraged. And then when it's not fun anymore, it's going to be very hard to learn. And it's going to be without the structure that kind of schooling and stuff puts into place, which is kind of nice about this course, is you're not really going to be wanting to dive into it. You have to make sure that it's still fun and there's still motivation. You're still, having a good time, and you're still feeling the passion. Because what will happen if you get over ambitious is you'll realize that you can't make what you want, and that sucks. And then you can, scope things back, but all of a sudden you're gonna get discouraged and you're gonna feel like you can't do anything. And that's not the case. You can still do a whole lot. It's just gonna need baby steps. So just be real careful about that. And it's something that I've gone through myself when I first started making game programming. I've told this story a few times, but I got defeated by a ladder. I was making a game. It was kind of like you were exploring the sewers in Paris, the catacombs, basically. And at one point, the way that you're getting out is you had to climb a ladder. So I was trying to program the ladder, and I would have been like 15 or 16 at the time. Would have been a long time ago with Unity. There was a lot of tutorials, but not a lot of stuff that was specific to, you couldn't really just be like, how to make a ladder go and then, implement it. There was solutions for it, but they weren't really going to fit how my player controller was working and stuff like that. And I was a 3D game, and I was trying to make the thing go up. So I'm like, all right, when I hit the ladder, I'll switch to something where now, pressing W will add force to go up and I'll move. But then what would happen is as soon as the ladder go up, I would shoot myself up either too fast, or I'd pop off the ladder, or I couldn't make it smooth, or it would go through the ladder, or when you're on the ladder, if you try to go down, you would go through the floor. It was like all these edge cases I couldn't handle. It got very overwhelming. I felt like I was a bad programmer at the time, but I realized how bad I was and how much I didn't know. And all these things I now had to figure out to make myself go up a ladder just felt like too much, and it wasn't fun anymore. And then it took me years and years to get back into that. I'm just going to read the question from Pookie. For 2D to 3D, one step at a time, how about mobile games? Once again, that's kind of the medium they're being played with, and this is something we can kind of talk a bit about. It's, the target for your game. Is it going to be a PC game? Are you going to try to make a game for a console? Are you going to try to make a game for a mobile? And what I'm going to suggest at the start is, start for PC, because if you're programming on one, you probably have one, I'm assuming. If you want to do mobile, you can. Unity makes it kind of easy, but then there's a lot of other stuff you have to get into, kind of like, optimizations for mobile, making sure you're not going to kill the battery. They're not as performant as most basic computers can kind of be, if you just have a graphics card, as well as the way that you play them are completely different. For most PC games, you're going to be using keyboard or mouse, or might have a gamepad. For mobile, you're going to have touchscreen support. Yeah. And being able to interact with, a touch event and where that's located on the screen and what that's going to do and all that kind of stuff can be kind of complicated. Yeah,
it's an extra layer of complication on top of everything. And if you're just starting out, start as simple as you can so you can grasp all the basic gotchas, and then you have a firm understanding of that when you add more complication, and it's less likely to stick you.
A really important thing about game programming is there is so much state management, and this is something that we always say all the time, and we joke about. We're like, "Oh, I broke the state machine," because that's kind of what games are, just a big glorified state machine, and it's many layers to it. But what a game is doing is it's calculating a state and then displaying that state to you via a camera or a screen, and that's what you're seeing. You're seeing this world in its current state, and it's just doing that. It's doing that as much as it can, for
as quickly
averaging.
As it can.
And you'll typically get like 16 milliseconds in between your peak into that state, and then that comes out to 60 FPS or frames per second. That's basically it. From across all games, all you're seeing is the state, what the current state is. That's kind of what you're telling the graphics card is. These are all the states. What is this going to look like? Show me what that looks like in this current. Give me a snapshot of what the world looks like. I'm gonna put that on the monitor, which is really cool. But also, it can get very complicated very fast, and also it's very weird to program versus other means, because state machines, you'll kind of have maybe one or two or a few of them depending on what problem you're kind of solving. But when you get into video games, like almost everything kind of has a state, which is kind of wild and can get a bit overwhelming, and there's not a whole lot of patterns that help with it, especially due to entity component system. Your state management is kind of now inside of your component. But this is everything from almost every game out you see will have some sort of state, even like UI menus, UI itself, what mode is it in, what scaling is it in, are there a theming for it? Is the button clicked? Does it change color when it's clicked? Is this button available? Is it disabled? All that kind of stuff. And then you start the game, and even just like a very basic game, is your character moving? Is your character jumping? Is your character falling? Is your character taking damage? Is your character attacking? Is your character defending? Is your character rolling? And then you apply it to enemies. Are enemies standing still? Are they moving? All this other stuff. And it sounds like this is kind of AI stuff, but it's not, because it needs to be accessed by everything. It needs to be accessed by physics. It needs to be accessed by, well, of course, AI controller, but also needs to be accessed by animation controller. What does it look like right now? If it's moving, we need to make sure that we're going to be rendering it in the animation state. And then there's layers to that of, which one to use. And it can get very, very kind of overwhelming very fast. It can feel very weird. But that's kind of the main thing you're going to have to get used to, is just having a whole lot of game state and having a lot of things to manage and planning out your game state before planning out or writing the code. It's typical for programmers before to, plan before you write code, which is a really good habit. And I extended to that for this is try to plan as much state as you can, because it'll make the process a whole lot easier. Because when you go to trying to go back and add state, depending on how many other areas, how many other entities are using that game object state, you now have to kind of update it in a bunch of other places to make sure that it still makes sense. If you add a new character state, well, now you have to make sure that your animation controller
will, have something for that new state or has a sensible default,
Yeah.
And there are lots of different patterns to follow while doing this. There's the concept of having a state store that you operate on. There's the concept of finite state machines within the class itself. There's the concept of using something like Flux that doesn't have, say, operations that happen on the store itself, but it has actions that are dispatched to the store that are given meaning. There's, just having a couple of state variables in your class rather than having an actual, FSM in there. I mean, we laugh, but it is valid. You don't necessarily need complicated state for a
I
lot
didn't
of things.
laugh. I cringed, just for the record.
Yeah.
Yeah, I'd go at least FSM.
There's a lot into there, and it also depends on like what you need. And what's kind of common now is a lot of event-based triggering and a lot of subscriber kind of patterns.
Yeah, pub sub, real good.
Yeah, because that kind of falls into what I was saying before. You'll have, what if you change or add a new state to like a game object? Well, now everything that uses it does it need to change, or how's it going to be? Or if you have it too hard coded or too direct, it's going to be kind of a pain. So what you see a lot of days now is kind of a lot of event-based programming for games.
I'm so happy. This is, again, in the weeds. I am so happy that event-based programming has finally made it to games, because it was the way that I managed state for a long time before picking up the Flux paradigm. And just like the way that the FSMs worked and the way that the state was driven in games just drove me batty because it seemed so backwards.
Yeah, it was a mess. Even just trying to like decouple the code was a mess. But so what we'll see now is everything's kind of just like action based. And as Rage was saying, there's kind of pub and sub, which is you'll have your actions kind of defined, and then you'll have kind of listeners or other ways of kind of hooking the objects of code that care about what is going on or what actions are being triggered, and we'll do certain behaviors based off that, and they kind of all chain together. So I'll try to keep it a high level example as possible, but for characters, let's say it's jumping. So you want your character to jump. So instead of having, just a Boolean or a state that is character jumping, you can still have that, but instead of having your objects and your external entities checking, on update, is the player jumping? And if they are, do something. What they do is they then subscribe to that action. And then when the player jumps, it triggers that and says player is jumping. And then all those listeners get that action and perform it as necessary. So you don't have to, it cuts down a lot of stuff too, especially depending on how the architecture is. You can't really be for looping through all your game objects for every little kind of interaction. You're going to want to be kicking off a bunch of stuff. And the ones who are part of that, subscriber or in that kind of data set of, should update if this action happens, will then update, and you don't have to, you just kind of dispatch that and let them do their thing. As well as it's extensible. So now let's say you want to add an achievement. You want to add an achievement for the player jumping 50 times, and you can even add a bit more conditions to this if you wanted as well. But previously you'd probably have to add that into the player controller, put a jump count in, and if the jump count hits 50, check if they have that achievement unlocked. If they don't, unlock it, hooray. But now you want to add more achievements for other things, and then now it's kind of messy. Now your achievement management is in each individual game object. What you can do is have a game achievement manager, and those things just subscribe to actions. So player jump, and now you can even write a script or have other conditional behavior separate from that, and now they subscribe to that. So every time the player jumps, when that trigger happens, this new module that's plugged in tracks that, increments it, and then can do that behavior when it hits 50. You're good to go. Well, now maybe you want it jumping in a certain room, or maybe you want it to be a long jump, or all this other kind of stuff. It's no longer, that code is no longer in the player controller. It's a way to kind of move things around a bit. But games are just so much state management. It's been a mess for a long time. A lot of action and event driven stuff now. So when you're getting into that, you're going to see everything as a state, and most things we're going to have, actions and triggers, and a lot of things are going to be kind of subscribing to that. May look a bit weird, maybe a bit weird to get used to. I promise it's worth in the long run to just get used to it. Don't try to reinvent the wheel at this point. Try it out, see how it kind of works for you. And a quick example to kind of, one thing we always talk about is the animation controllers, they use the information as well. Now they can be a bit more abstract. They can now, it doesn't have to be the player object. It can just be, a certain type of player, or you can start using a bit more types in there, and now they can start using animations on top of that. So, certain player types or certain character models have certain animation timings or certain things like that. They no longer have to be attached directly to those controllers or the code. They can, still be in an animation controller. It just gets identified from the trigger or which one triggered it to what value then gets set for it. But sometimes this goes wrong, and this is kind of when you see T-poses in games, and this is where the animation state has bugged, and that's usually the default pose, and it doesn't know what to do with it, and all of a sudden you now have a T-pose on the screen running around.
Yep. That's a T-pose in the chat there.
One of my favorite ones in recent memory is the player movement state animations when they're on motorcycles.
Yep. I was thinking of the same one.
Bug out in Cyberpunk, and then they're just T-posing on top of a motorcycle.
Yep. It failed to load the animation for riding motorcycles fairly often. So typically you'd get on your motorcycle and just stand on top of it and T-pose around the city on top of a motorcycle. It was pretty wonderful. I love you, Buggy Punk.
It's just stunting. You're doing a stunt.
Yeah. Is it Buggy Punk or is it just Cyberbug? I think Cyberbug is the proper one.
I think it's appropriate to both. My God. we've got a bit of time left, so I'm really curious if anyone has any questions or wants kind of examples of certain things for games, or things they're kind of uncertain of, for what's used for certain game programming or stuff like that. So please shoot away, ask anything. If I don't know the answer, which I probably don't because I'm not that experienced, I will try my best to find it. You can join a Discord and ask me there as well. But in the meantime, I'm just going to kind of paste in.
We can go over some game math and stuff too before the end.
Sure. I just pasted in just kind of a lot of areas of game programming. So this is kind of stuff that I'd assume that some people would have some questions about, and we can kind of touch on them a little bit. These are kind of some topics, and if a lot of people are very interested, we can even expand on this and even pull them into some into some later panels, because I think we did one on graphics and stuff like that, kind of what graphics are in games, but we can even expand on those things further. When things even like dev tools, engines, and physics, AI, all that kind of fun stuff.
There is a channel point redemption for requesting a panel on a topic. So here you go. Here's a list of things to request. Can you touch on a little of visual scripting and the good/bads?
So that's for things like Blueprint, like the node-based kind of editors where you're not really directly writing code, but you're kind of plugging and playing. Yeah, sure. It kind of depends on the implementation. We're seeing a whole lot more of them now, and there's going to kind of be growing more and more. But at the end of the day, when you're programming, that's kind of all you're really doing is using functions and putting data into that functions and maybe changing the value for a bit and then moving them out. Especially when you're first getting into programming, you don't really need to be writing actual too much code, and that's the kind of beauty of these new node-based editors that are out there. For example, like the Unreal Blueprint, the good of it is that it simplifies the whole process. You just need to know what functions you want to call and what you want to put there, and all that stuff is kind of handled. You don't have to be writing the raw code, because at that point a lot of it's just kind of redundant anyways. Where the bad kind of comes in is that it's a level of abstraction that's kind of easy to get very messy, and the patterns haven't really been found out too much to how that should look or how much should be in Blueprint versus raw scripting, as well as there are limitations to the implementation of some of those functions. Not every Unreal function is available as a Blueprint node, but you can write custom nodes. But then, as well as that, it's kind of like you get a feel for it. It makes the overall process a lot easier, but there can be some performance and optimization limitations, as well as just a bit of confusion down the road. But I'd say more than not, start off with blueprints, especially for prototyping. If you get to a point where you need to optimize, you can easily convert from that to actual code, because your logic is there, what you want to do is there. You can get around the limitations that way.
Yeah, and that was something that I was going to bring up as well with blueprinting and similar paradigms for setting up games. Is very, very good for prototyping, very good, but they generally run like crap So you're going to want to go implement them properly later on once you're getting closer to, release time.
That's kind of one of the beauties of blueprints as well, is it's parceled in such a way that it's designed that you can pull that blueprint out once you've found the settings you want for your game and drop in a C++ code piece, so you can start actually tweaking and tuning and going for all the efficiency you need in that piece. Keep your logic all in place.
It gives you a nice visual representation of the behaviors you have going on and the connected nodes and what's where and what you need and what's being used and all that other kind of stuff, especially when you get to like logic and you're sort of doing AI kind of stuff like that, but even just state management and looking at state triggers. And then when you want to make things more efficient, you have an actual visual representation that you can kind of use as a diagram and as a basis of what you're going to be writing in code, which is very helpful. It's nice to have those kind of areas of what this thing is going to need to talk to, what it's going to be used for, where the location of this should be and all that stuff like that.
Yep. Yeah, all of those little problems all of a sudden become actual problems when you go to try to program it.
Yeah, Node, we're going to be seeing a whole lot of those almost everywhere pretty soon. Because Blender for like shading and all that stuff, it uses a node editor and it's fantastic. I mean, it's all those for when you're doing like that kind of graphics programming for like modeling and animation. It is just functions and values that pre-exist, and you're just tweaking things, and you don't have to be doing that in Python or doing that in code by hand. It is just a function that you can just click and drag connections to. This texture that's loading from this file loads into this other texture, or mixes with this one based off these values, or based off this kind of data set or anything like that, or I want this to weight against a value on this one. And I won't try to get too complicated with it. And I know this might not make too sense for people who haven't seen node editors or anything, stuff like that, but it lets you kind of just plug and play rather than having to write a whole bunch of code. And what takes me a minute in Blender would take me an hour in Python, kind of idea, as well as just being able to have them and visualize a lot of that stuff is a lot easier than trying to figure out just based off function names, kind of what's available and what's there.
For sure.
And that I think is something important to call out as well. That what takes you a minute in Blender with their node editor, if you had to write a plugin for that, would take a long time. That's instead of paying that cost at runtime, you can pay that cost of building that model, making sure that all of your connections are mapped correctly while you're building the thing, rather than in real time when you're trying to run the video game.
Yeah, anything you can pre-render saves you a lot. That's why we were seeing 3D environments on the SNES pre-rendered, because it was all baked at build time.
Gonna look up tables. But yeah, I've seen some flack that people get for blueprinting their games, and it's one of those things where if it gets the job done at first, like don't worry, don't stress too much about that. Get it there first. When it's game programming, as I was saying before, it's more behavior programming than actual programming. You're going to be more sort of just scripting things, make them feel and behave right, and then kind of worry about getting the optimizations there, because you can still keep that same logic for the look and feel of things, and then worry about what do I need to do to make them run faster, because like I said, you can have the most optimized game in the world, but if it's not fun or if it doesn't feel right, it's not really going to matter.
Yeah. And also, don't forget the proper answer to anybody criticizing your game that way is, let's see your game.
Yeah, show me how you did it, because odds are they didn't.
Yeah. Yeah.
But if they did do it and it is better, then you can learn from that.
Yeah.
So that's awesome.
Yeah. If they've open to suggestions and they're going to help you, then that's fantastic. But unfortunately, there's just a lot of people who just,
they just like to shit on things.
And that's why Dez's answer of "where's your game" is a good response, because half the time, they're not going to have one, and half the time they're shitting on you is because you'll see this a lot in unfortunately the game dev world as well, where for the longest time people had an aversion to game engines, and I was unfortunately part of this too, where it's like, oh, it's doing everything for you, and it's like it's a cake mix, right? It's like, why would I use cake mix? I know how to make a cake myself. It's better when I make it. And to be honest, not like realistically, not all the time. That's not, just because you put more effort in doesn't mean it's going to be better. There's reasons why people have optimized these workflows to this sense. And I think some people get very frustrated that they're spending months, writing an engine from scratch, and then someone spends the same 2 months, making a game in Unity, and all of a sudden now it's playable and ready and all other stuff, right? I could see why that'd be frustrating. And I went to a game jam one time, and for some reason we didn't try to use a game engine. We tried to write one, and we got one, kind of written. It was buggy, and it was 2 days, but at the end of the day, we didn't have a game. We could shit on game engines all we want, but at the end of the day, we didn't have one. So don't worry about it. Let them talk their thing. Ask if they have a game. If they do have a game and it's running well with the things they're saying, then, listen to them, because they're probably actually going to help you. But if they're just kind of talking shit and trying to put you down to make themselves feel better, just, ignore them.
With a little caveat here. I would like to point out that it is often very beneficial to try writing an engine yourself.
Oh, yeah, totally.
Just to realize how much goes into it. Like, even in the web world, rather than just reaching for a library and using it, even though that is the most effective way to get things done, use libraries. I will often, at the very least, read the code in the library, if not try and replicate it myself.
Yep.
Because, the person who has written that library, as long as it's vetted and used by the community, they did it right. You don't have to worry about bugs and edge cases. If that library is already widely adopted, it has those covered. They did it for you. Do it once yourself. Figure out why it sucks, but then use the library.
Yeah, it's not only becoming humble, Pookie, it's also knowing what you're using and what you're asking the thing to do. So once again, Game Institute, I keep pimping them. I'm going to keep pimping them because they really are that good. Throughout the whole C++ course, how they teach it is, okay, here's the basics of a linked list. Now go write one.
Okay, and now that you've done that, never do it again. Yep. Use this library.
Yep. Now then they say, okay, now that you understand what it's doing, here's the library. But because you've written your own basic one, you know what you're asking the library to do when you get it to do the thing. And they continue this trend right up into 3D render pipelines. Okay, here's how you write a basic 3D render pipeline. Now that you know what you're asking it to do, never do that again. Here's OGL. And now you know what you're asking OGL or DX or something like that to do because you've done it before. They're going to do it better than you, and they're going to handle errors, and they're going to do it faster, but you get the concept of what you've requested it to do.
Yeah, it's important to do it once and then never do it again.
Yeah, especially when it comes to the math side of things with game programming as well. Like I said, you don't have to have a full understanding, but you should still be aware of when you get to the point where you're calling specific functions. Like if you're calling transform and stuff like that, or you're calling like the rotation or anything kind of with matrices, a lot of engines have libraries that handle this for you, but it's really helpful to understand what's happening under the hood, because when you start getting weird behavior, or things start rotating in a way you didn't expect, or things start moving in ways you didn't expect, when you have a bit of foundational knowledge to what those functions are doing, it really helps in the debugging process. Because, maybe you're passing in a wrong value, or making an assumption that's not there, or, maybe you're calling the wrong function, or all this kind of stuff. It helps. So it's good to have that foundation knowledge, but yeah, always kind of don't try to reinvent the wheel unless you're at that level where, you know more than they do, which at that point, this talk isn't really for you. At first, and it's hard to gauge when you're at that level, but it's kind of at the point where it comes up down to you, and you'll be at the optimization point anyways, and you're just trying to figure out what's working and what's not working. But for the most part, use what's provided, but make sure to understand it. Don't use it blindly. I know it can be kind of dry to read documentation and read code, but it goes a long way, especially when you start getting into debugging and even some optimization.
Yeah, the optimization is the big one. You really need to know what you're asking it to do under the hood to optimize it. You cannot have those black boxes. They don't work.
You got to understand what you're asking for, and then you can go ahead and not really care and just use the API. But just that understanding of what's actually going to happen when you make that call is very important.
We've got like 5 minutes left. Are there any questions? Before I just let people pseudo ramble for 5 more minutes. Because we all love pseudo rambles, but we love questions too. We didn't really get to go into anything math, so maybe we get like 5 minutes of actual math at the end.
Sure. I'll try to... if we want to watch a cool video on what a shader is and some really,
I don't think I can
that,
stream their video.
that's fair. For people, if you,
we'll have the link to the video in our Discord. Make sure you join the Discord. Or we have a whole community that does this all the time on the Discord.
There's shader competitions, which are really cool, and they're programmed live. So basically, two people are, previously they would go on a stage, and now it's kind of more remote. They live program a shader, and what a shader is basically just a program that's going to run off your graphics card. And originally, it was for shading, things in games or shading models for animations and stuff like that. But now can be a whole lot of things, and it's kind of just a lot of really cool effects you'll see in games. You'll see them referred to as shaders.
That name confused me for so long.
Basically, what it boils down to is math to run on graphics card. This is math you want to process on the graphics card. Stuff you want to calculate with your graphics card is going to be a shader. And these competitions are really cool. They set up their live program, so it's something they make, I think, in 20 minutes. And it's these super cool, like, looping animations that are just, they write a program with a bunch of for loops doing a bunch of kind of crazy math that I don't even really understand. And it runs and makes these crazy effects. But a level above that is just when you're getting to, for at least 3D, you're going to want to know a lot of vector calculus. And it can be kind of a pain, but you're going to need to know matrix transforms. You're going to kind of need to know how to exist in 3D space, as well as understanding what a game camera is doing. Because at the end of the day, all games are actually 2 dimensions when displayed to you, because your screen is 2D. That's got some crazy holographic monitor or something going on. The game needs to, when you're doing a render pipeline, it needs to figure out the position for everything, but it needs to calculate how it's going to look from a spectator at that point of the camera, but then also take that and translate it into 2 dimensions and have it still look 3D, which is just kind of nuts and crazy. I'll see
a lot of math involved in game cameras.
A lot of math involved in games. Period. Every piece.
Which is one of the reasons why we always find the movement bugs in games and go, floating points.
Yeah. Anybody who knows programming should understand pretty well the follies of floating point. There are issues with floating point, especially when you're looking at converting binary to decimals and decimals to binary. When you're trying to make like a finite decimal string with a large decimal number at the end of it and convert it to binary, a lot of the time you just end up with an infinite repeating binary string in your conversion, and it doesn't translate well. So you end up with all these crazy holes in your math when you're using floating point. And then you get to programming games and you realize the whole worlds are programmed in floating point, and you go, oh.
And that's why things sometimes just take off into the stratosphere.
I think Doomtunes had a question regarding, is there a more difficult game to create? And for the most part, as we were saying, it's scope. With one exception, and that's MMOs. That is the
MMOs are harder to make than anything.
Yeah, those are the ones that require, like, I don't think you can make it cheap. Figurative cheap. Like, you're going to need millions to actually make an MMO, just because of how complicated those things are.
We're down to a few minutes, so I can quickly tell my favorite story of this. There is on Steam, or at least was on Steam, I think they stopped selling it, a game developer package to help you make an MMO. It's like everything you need to start making an MMO. And in the reviews, it was just negative. Like the number one review that everybody liked was going on and on and on about how all it is a bunch of code and a database. Like, I don't know databases. How am I supposed to use this? And then the number one response to him was, if you don't know databases, maybe you shouldn't be trying to make an MMO.
As it turns out, data replication, pretty important for having a persistent world.
Yeah, yeah, that is exactly what this is. It's all that code in a database, so you don't need to set up that database or the code to access it, because that is really what an MMO is. It's just a big database that a whole lot of clients access and update at the same time, so that you have a okay, we've been talking this whole time about games are just a bunch of state, so MMO is just a unified state that a whole lot of clients read and draw.
Millions.
Is really, yeah, millions of clients read and draw at the same time. Yeah,
and it turns out that's really hard.
Yeah, you know the basics of SQL, so imagine all the players on a WoW server accessing the state for that server, updating it, and drawing it to their clients at the same time.
As well as accessing all the information for the items they have, for descriptions and for loot and all that other fun stuff.
And everything else that's being drawn on the screen.
Yeah, imagine all of that stuff is coming out of a database and all of those clients are drawing it from that server at the same time. This is what MMOs are doing.
You can't have write locks, you can't deadlock, everything needs to be concurrent.
I
have
It just makes me laugh when I think about it.
I have one quick thing I wanted to mention too for people starting game programming, and it's going to be very tempting at first, is multiplayer. Do not start with multiplayer. Save that for get a solid foundation of being able to make a game, make a few games, even if they're just 2D, and then jump into multiplayer, because you're going to dive into a whole other beast, part of which isn't even game programming. You're just getting into network stack and network programming in general, but then also making it work in a game is an absolute nightmare, which we can touch on sometime. It's kind of neat, but also very complicated and can get very overwhelming fast, as well as you'll make a multiplayer game and then someone with a bit more knowledge of you then writes a hack and then you're kind of screwed.
I got so much to learn, and hello, yes. You see, realizing how much you have to learn is a huge step up in Caria. That means you've gone from the beginning of the curve closer to the middle of the curve. You're getting into it, because at the beginning of the curve, you're like, this'll be easy, I'll just make a game, because you don't know anything. And then as you get to the middle of the curve is when you start hitting the point of realizing how much actually goes into it, and that's when you start feeling like you don't know anything. So you go from feeling like you know everything to feeling like you know nothing to being competent and knowing a couple areas and knowing who to ask for the rest.
Yeah. At the start, you don't know what you need to know. You don't know what you don't know, and you don't know what you need to learn. So it feels like you have what you need. So it's very easy to get ambitious. But knowing what you need to learn is a fantastic point to be, because learning that stuff is quite fun, and it gives you kind of an end goal, and you know what you need to do, and that process is just going out and doing it.
Indeed. All right, we've even gone a little late. One day I want to make a homebrew, or maybe it's a ROM hack for SNES. So they're different. You can do homebrew for SNES and you can do ROM hack for SNES. It depends if you're starting with a blank slate or you're starting with someone's ROM that you want to modify. ROM hack might be easier, since you do have something already built and you're just modifying. If I was rich, I would just hire and point at stuff. Yes! That is what I would do as well if I had the money for it.
You can, nowadays, it's a bit more possible to hit that producer role, where if you can prototype something, if you can get your idea down in a game design document filled out, as well as try to throw together a prototype, you can go to publishers, and depending on how your game is, if they like it, they will throw money at you, and then you will just be able to point at people and get them to make your game for you.
Yep. I just want a Super Mario RPG too. We all do.
Everybody does.
Everybody does. But the team that made it has died and is buried and has rotten away, and there's nothing left of them, and it's sad. It is sad. Might do that. Yeah. If you're already on the Discord, I know that for a fact. So ask in there. There are people already doing similar things. We have at least
Egg
one
specifically has looked into doing things like that. Going to speak to publishers, who you want to talk to, how you want to talk to them, what documents you need to have. I was working with him on that for a project a ways back. So when you're at the point where you're ready to go talk to publishers, maybe ping Egg, see what he's got for you.
Magic Gong also has already hired people to to build pieces for his game and is managing a team doing it. So there's definitely experience in the Discord already doing this. Ooh, excuse me. I think dinner should be here soon. I'm pretty hungry. I'm gonna come back. We've already gone
Words
over
are
how
hard
hard
today.
words are today. I'm gonna come back and play Sekiro, and hopefully that goes better than talking. Is playing Sekiro easier than talking? Find
Yes.
out later. However,
Yes, it is.
until then, thank you all so much for joining us. I hope you've enjoyed. I hope you've learned from it. Bring those questions to the Discord. Use those channel points. Request some panel ideas. Next week will be review of Resident Evil 4 and Yakuza 3, the first game to ever make me give it up. Stating that officially.
Well,
I'm not-
since you started the channel, anyway.
Yes, the first game I've ever given up on stream. I just can't do it. I need to grind side quests so I can pay all my money to go do daddy daycare, and I don't care anymore. I just don't. But we'll be doing the review of RE4 as well, yes, and that game was fantastic, and I look forward to talking about it. A whole bunch.
Yeah.
Sekiro later, probably some Pew Pew later, I'm assuming. That usually
Probably.
happens. And Monday will be Control, that means.
I think you're really going to like the story for Control. I don't know how much you'll like the core gameplay. So it'll be interesting.
I'm sure I'll like it more than what I was just playing.
Probably.
Yeah, that's unfortunate. You got that recently. Yeah, I look forward to it. Heard nothing but good. Anyway, food. So until later, I'm Deus.
I'm Rage.
And I'm Pseudo.
And may all your shots be headshots.